Hi, everyone. Welcome. Thank you guys so much for joining us today for a Marine Technology Society member webinar. I'm Abby Wakely, Manager of Member Engagement, MTS, and your moderator for this session. I'm super excited to showcase the impactful initiatives from our MTS member, Blue Robotics. But before we dive in, I want to kick off with a brief overview of Zoom webinar. As a reminder, the session is being recorded and will be shared with everyone registered. Attendees are in listen-only mode. If you have technical questions for me, I highly encourage you to please type them in the chat box, which is signified by the double conversation bubble icon. If you have questions for the presenters, kindly type them in the Q&A box, which is the conversation bubble icon with the question mark in the center. You can do this anytime during the webinar, and we will pose to the presenters after their presentations. All right, now that we've done the logistics, let's get to why we are here today, the webinar. We're really excited to have two team members from Blue Robotics, Eldin Miller-Stead and Kenneth MacCallum, to discuss priorities and ethos towards development for the coming year. They'll discuss where they see the largest gaps in the specific challenges that they are working on to enable leaps in what is possible for accessibility in marine robotics. Eldin leads Blue Robotics research and development with energy and optimism. He sets a high technical bar for the company and his team and contributes his creativity and experience to many of the biggest design challenges they tackle. Kenneth is an innovative technical leader with a track record of creative, novel solutions to ill-posed, multidisciplinary problems. Kenneth brings 30 years of product and development experience across multiple industries, from marine robotics to medical device development. He is eager to tackle complex acoustic and communications problems in marine robotics. All right, let's go ahead and get started. And Eldin, I'm going to pass it to you to take it away.
Awesome. Thanks so much, Abby. I'm Eldin, the Director of R&D here at Blue Robotics. So yeah, thank you so much for joining us, everybody. We're really excited to share some of the things that we've been thinking about, that you might care about, and that we're working on today. So yeah, let's just get started. Oh yeah, sorry.
Yeah. I'm Kenneth MacCallum, Principal Engineering Physicist here, like Abby said, and I lead electronic development here at BR.
Are we sharing?
No.
Oh, okay. There's no... Sorry, Abby, can you see our presentation or?
Yes, we can see your presentation.
Okay, awesome. Okay, sorry. we had technical difficulties. Okay. Sorry. There we go. Awesome. So today we're gonna focus our conversation on kind of two things. We're going to talk about a bit about who we are as a company, kind of as a team, what drives us, what motivates us, why we're working on the things that we're working on. And then we're going to talk about the things that we're working on. And a lot of these things really depend on you. They really, both for adoption and for their success. And so that's why we're sharing them today. It's not everything that we're working on, but it's just a few things, and we don't have a ton of time. So we're going to be focusing a bit on our thoughts about the future of what subsea vehicle architecture is. So as far as connectivity and how stuff talks, we're going to talk about a bit about what we dubbed Project Blueberry, which is a new initiative that we started that is both an open source Ethernet protocol for device communication and a whole ecosystem of hardware to support that. We're going to talk a bit about our new Subsea connector, which I'm sure a lot of you are excited about, and we are too. We're going to talk about the efforts that we've been making in thrusters. So we've been redesigning our thrusters, and we have all of these ideas for new sizes. And we're going to talk about our new 4K camera that we're trying to launch this year, and also the future of what we see subsea vision and open source cameras are. And we're going to talk a bit about our efforts and the future of our open source acoustics. So to get started, I'm going to talk, kind of introduce the team a little bit. So you can hopefully walk away with a bit of a better understanding of kind of who the humans of Blue Robotics are. So this is a picture of most of our production team down in Torrance, California. We've got our team in Canada, which is in the top right, our remote sales, marketing, and support team in the middle, and then our software team in the bottom right. And they're all kind of distributed around the world. So we've got 3 main locations. So as I said, all of our production environments, so our manufacturing, our quality, our shipping. When you place an order on the Blue Robotics store, those products come from our warehouse in Los Angeles, and that's where all of the assembly happens. So all the raw parts come in. We've got our hardware and firmware development, so basically our new product development in Victoria, BC. So we've got about 15 people here. So that's kind of the top right photo there. And then we've got our software team in Brazil, and they're focused on BlueOS, Cockpit, RGSub, and our Mavlink to Rest, and a bunch of other software, open source software related projects. We're not going to talk about software today that much. We're going to be mostly focusing on the hardware and the new products. So overall, we've got about 80 people across the company, and some of you are probably our distributors. And so we've got around 60 of them now in about 30 different countries. And we just kind of consider them an extension of our team, really. They're just amazing to work with. So a little bit of map, kind of where we are in space here. And then our sales and marketing teams kind of distributed around the world. So I'm going to talk a little bit about our mission, kind of what drives us, what motivates us. So some of you may know, but just to kind of recap, our mission is to really enable the future of the whole marine robotics industry with accessible components. Much of what we do is driven by cost. We want to, there are many companies out there doing things at very high cost, and that is awesome, really pushing the boundaries of what's possible in terms of the technology. We like to think of ourselves as doing that, but doing it at a higher volume, lower cost way that is very, very challenging in and of itself. And we believe that this is one of the most important things to enable the entire industry at scale, is to be able to produce these building block components for companies, researchers, students, and have them enable them with the tools to build the stuff that they're build the robots and the things that they're trying to build to do the end application that they're working on. And so our customers are not, like many of you, are not consumer level people. Like, you're researchers, you have companies, you're using these products in a whole bunch of different ways. You have you're technically inclined in some way. So we try and support that by, providing lots of documentation, learning materials, and tailoring our stuff towards more technically inclined people. So you won't find our stuff on Amazon. And kind of lastly, a really big objective of ours is to really build a company that lasts a long time. So we don't want to just be like many other startups and build our company very quickly, scale very quickly, and then sell it or get acquired by somebody. We want to really control the whole technical direction of the company, really maintain a lot of kind of community within the company and outside of the company. And it's just really important to us that we build an awesome company of awesome people, and that we leave a really positive legacy on everything that we touch in our products. So a little bit of history. So we started in 2014. So Rusty, in his garage, built the first thruster. And in 2014, our Kickstarter campaign raised $100,000, and we sold 600 thrusters. And what was a really interesting and amazing outcome of that is we really saw that, okay, there's not just demand for thrusters, there's demand for a lot of other kind of building block components in marine robotics. Like, the world is thirsty for a lot of these inexpensive components that that were really coming out at the time, and flourishing in the drone space, but really there was not any options in the marine space at all. So there was, yeah, a whole variety of needs, very strong demand, very few affordable solutions out there. The stuff that was out there was quite old. So the and yeah, so it really was all of the right conditions in the beginning to really fire out a whole bunch of products, fill a whole bunch of gaps really quickly, and that's what we did. And now we're actually almost 10 years later. It's almost 12 years now, and things are going really great. So we have over 400 products that we manufacture and sell, and we've designed. We've sold almost 200,000 thrusters. We've sold over 5,000 ROVs and over 1,000 blue boats. And I think most importantly, our customers and the people that use our products have grown with us. They really rely on us a lot more. And as we grow and as our stuff matures, and as we mature, so do like the people that rely on our products. So quality and reliability has been more important to us now than it ever has been, because people and companies that are even bigger than us really depend on our stuff, and we're really aware of that. And it's something that is really front of mind all the time for us. Is that being said, and what makes development really challenging is to both ensure that the reliability of our products and quality is very high, and also keeping them accessible. And that's where the engineering challenge is, I think. And so we're trying not to go backwards on the accessibility and cost, yet still make things that people can depend on, and that's just turned out to be really difficult. So another thing is we've grown. The community around our open source software has grown a lot, and our last MTS webinar was based pretty much all around that, and that's just one amazing outcome of growing. And I think as we grow, we want to become more open. We want to share more stuff. We want to open source more software, but we also want to open source more hardware too. We feel like it's only been a positive thing to be very transparent and share what we're working on. And we want to continue to do that. So, so yeah, just some kind of a splash of a bunch of the different things. If you're not aware that we sell, we've got lights and thrusters and enclosures of all different sizes, tethers, vehicles, cable penetrators, acoustics, sensors, actuators, all sorts of stuff. So we're continuing to build that out, and we're also reimagining it all of the time. So yeah, so that kind of a bit of a segue into what we're working on right now. So we're going to be focusing, on 5 or 6 of our big product development initiatives. And I'll get Kenneth to start us off.
Yeah, first of all, we're going to go kind of rapid fire here a little bit. And so any questions that pop into mind, I encourage you to do what Abby said, and we will hopefully get to them at the end, because I'm sure lots of things we say you'll go, huh? And probably want to know more. Unlike a lot of people in industry who are talking about the thing that they're working on right now, we're not going to be talking about AI so much. I think a lot of our stuff fundamentally is useful to support all of our users who are pursuing those sorts of goals. But we've got a lot of work to do in the hardware realm. So first of all, I want to talk about connectivity. As you've all found, components are getting more complicated. They're getting smarter. It's becoming more and more, I'm going to say, a challenge both for end users, but also for us as developers to hook them all up and make them do what they need to do. There are no standardized protocols, or not very many standardized protocols, that work really well in this space, especially when we talk about components that span, let's say, from something like an ESC or a gripper all the way up to sonar and cameras. No standardized connectors. So again, it means that our users are having to get right down to the wire level, rip open their cans and do stuff every time they want to integrate a thing. We feel that pain quite a lot ourselves. Reliable connectors are expensive. And if you decide that you want one, today, well, you're going to have to wait a little while before you actually get it in your hands. There are some low-cost connectors out there. Unfortunately, reliability seems to be an issue there. Broadly speaking, connecting stuff is still a pain. So imagine, if you will, imagine that a vehicle is really just a subnet, an Ethernet subnet. Everything is open source. There's common connectors. We've got common interfaces. There's reference electronics, so people don't need to reinvent things if they don't want to. And common protocols, so that as much of the effort as it takes to make a multi-stack communication environment all the way from hardware all the way up to software, we don't need to be doing that again and again and again. Common libraries to support all of that, plug and play for the users. So if they want to add a gripper, they just plug it in. And we all want it to be fast, and we want it to be higher bandwidth than ever before. So we started this internal initiative called Project Blueberry, and it's kind of multifaceted. It includes a protocol. It's which is sort of a hybrid, I'll say, pub-sub architecture. But also we've got hardware reference designs. Obviously, we've also got the hardware built into a whole bunch of our new and upcoming products. We're leveraging an Ethernet protocol that is new in the automotive space. And I think it supports a lot of the lower cost, smaller devices that you might otherwise think Ethernet's not appropriate for. For instance, they share copper, it's multi-drop, so that you don't need to have a separate switch for every single node. All in all, this is going to make connectivity easier, we believe. It's going to make control and telemetry richer, so we'll have more bandwidth to say stuff. Devices will be able to say more stuff and more varied stuff. And obviously, like everybody wants, we want higher tether bandwidth.
So an important part of this whole kind of interconnection and all these ideas is really comes down on a hardware level to a connector. So we've been working on what we call the WetLink Connector for ever. It feels like forever, but it's been probably pretty seriously about 5 years now. And we finally have it to a point where we're almost ready to share it with the world and get it out there. And we're really, really proud of how far it's come. So we've somehow designed it in a way that doesn't use any potting at all. So there's absolutely no glue in the entire assembly process, which is, I think, pretty rare, or maybe even just doesn't exist right now. Which is amazing. So every single pin, every single interface is sealed with an O-ring or multiple O-rings. And the cable is sealed with a compression gland penetrator. Which means that the connector, even though it's a dry make connector, is completely water blocked. So it has the same rating, open and closed face, and that rating looks like it's going to be about 1,000 meters. So yeah, we're leveraging our WLP, so our WetLink penetrator compression gland geometry and seals in the back of the connector. We've got a bunch of different variations of inserts for the M10 size. So we're starting with the M10 size of the connector. We obviously have some M14 WetLink penetrators, but we don't have any M14 connectors yet, but that will be in the future. We designed a tool that can assemble these connectors in the field. So if you're really good, you can do one in less than 5 minutes out on the boat. And if you're new, it maybe takes around 10 minutes to terminate a cable. And just like WLP, you can really use any cable diameter between 4 and about 9 millimeters in the M10 size. So it works with almost any cable you can imagine in that size range. And we've been doing a lot of testing. We've gone through well over 3 full refreshes of the design, complete redesigns, and over 30 iterations of all of these designs to get to the point where we're at right now. So we've been doing thousands and thousands of cycles to 1,000 meters at putting them through our entire product validation process, down to extreme temperatures, up to extreme temperatures, running current through them, all of this stuff over many, many iterations. And we're really, really confident that this is just an absolutely bomb-proof connector, and we're just so excited to get it out there. So another thing that we're putting a lot of effort into, and we're really excited about, is our new thruster design. So why are we redesigning our thrusters? Well, they're really important to us. That's how the company started. And I think maybe some of you are even asking, why don't you have more thrusters? And the reason is that the current design, although awesome, is actually quite difficult to scale. So we are producing about 500 thrusters a week right now. And people are pushing the thrusters harder. They're expecting more of them. We're expecting more of them as time goes on. We see a lot of demand for both smaller, lower cost thrusters, and also larger work class thrusters and higher voltages. And the reason that we haven't done that yet is because we basically needed to start at the drawing board again and redesign our thruster architecture so that it's more scalable and it's less sensitive to vendor issues, supply chain issues, and manufacturing variability in the design. And as some of you know, last year we've been having some thruster supply issues. We've hopefully resolved much of them, but the new design is going to absolutely prevent that from happening again, and allow us to scale our thrusters up in size and down in size really quite quickly, which will be awesome. And another thing is we'll be able to have likely 1,000 meter depth rating on all of our thrusters. And right now, that's even having a consistent depth rating has been quite difficult on our T200 and T500 thruster. So the new design is it's going to be likely 1,000 meter rated. We're doing all of the subassembly processes in North America at our Torrance location. It's going to be so much more robust in like every way. We're not relying on potting at all for any type of sealing. So we're only sealing the assembly with O-rings. And then we're doing the encapsulation with thermally conductive urethanes, all in-house, which allows us to be a lot more flexible with our supply chain. It allows us to dual source or triple source a lot of our different components so we don't run out of them. It allows us to control all of the assembly equipment that puts all of them together a lot more tightly, so to control quality a lot more tightly. And we've designed the thrusters in a way to accommodate integrating the speed controllers into the thrusters in the future. So we've been, in parallel with the new thruster design, been working on a new open source speed controller. And this speed controller, we hope, is not only going to be useful to drive our motors, but be broadly useful in the robotics community as just a really awesome, very power dense speed controller. And we're trying to do it at a very low cost. And in general, the whole architecture of the thruster is much more sustainable as we go up in size. And the motors will be much easier to extract from the thruster, because right now, you'll notice that we have the T500 thruster, but we don't have the M500, and it's because they're actually like very different. And in the new architecture, the M500 is just, or the T500 is just an M500 with a nozzle on it. So it's the core of the thruster now, and we made propellers easier to change out. I won't dwell on this too long, but here's a little fun exploded view of the new architecture. So we're using the WetLink penetrator to seal the cable. We're encapsulating the entire assembly with urethane. We're O-ring sealing everything and injection molding everything. It's going to be awesome. With the rotor, we're actually using some new manufacturing technology called metal injection molding. And we're overmolding plastic onto a metal injection molded rotor core. And this is completely new and like really, really cool. And we're doing all of the magnet assembly and the entire rotor assembly in-house, and we're vacuum encapsulating the rotor as well. So both the stator and the rotor are going to be completely void of air, and be completely vacuum encapsulated and filled with urethane and epoxy. So on to the next thing. So we're also working on cameras. So we're both working in the short term to satisfy a real need for high resolution cameras, but we're also working in the long run. So I'm going to focus on the short term right now. So we've developed something called the RadCam. It's a 4K 30 FPS subsea camera. And we did this because, well, the world has kind of demanded it. Our current 1080p camera is not it's not super high resolution. It's fixed focus. It doesn't have very good light performance. It's a very small sensor, and the demands of imaging and kind of, I think everyone that is used to doing anything with cameras, especially with your phone, really is expecting more from cameras. So we really have felt this need for a long time to develop a new camera for the ROV, and the unfortunate thing is that it's very difficult to just drop a camera into a subsea environment and have it work perfectly. There's the light environment makes it very difficult to get proper white balancing. The focusing is an issue. So there are not many options out there. So we really had to start from the basics and build something ourselves. And it's just so important because, it's the primary reason for many vehicles to exist, is just to look at something underwater. I do want to acknowledge that there's some actually really amazing companies out there doing lower cost now subsea cameras, and that has been really awesome to see. We have a couple as reef products in our store, but this is still a huge focus for us, and we're doing a bunch of development on cameras. So the camera that we hope to release this year it's a 4K camera. It's based on the IMX678 sensor. So it's a 1/1.8 image format. It has really awesome low light performance, especially compared to our current camera. And it's relatively low cost. We don't think it will add much cost to the ROV at all by integrating it. We're going to start with a zoom focus lens. So variable zoom focus, and then we'll have a fixed focus option either around the time we launch it or shortly after. And there'll be several options for fixed focus lenses. We're making a kit that you can retrofit your ROV with first, or you can just buy the camera itself and the camera module. And then we'll be making putting them into enclosures so that they can be mounted externally as well. So just some fun pictures. Thought it'd be fun to share. So it's one of like the first prototypes of the camera on the left. This is a couple of years ago, and then through many iterations and injection molded tooling, we finally got we assembled our first unit from all of our tooled parts. So that's kind of a fun progression. And then we started building lots of them. getting them out into the world, getting them out to beta testers, getting lots of feedback, and realizing that, wow, it is actually really, really difficult to make a software load onto a camera and set up everything in BlueOS and Cockpit, and to make the camera just work across all of the different light conditions that exist in the world in the water. So it's been, it was working great here. It was working great in Hawaii, not working great, in any random light condition. So it was very difficult to get the white balance working well. So we've been working on that a lot over the last year. The hardware has been in a really good spot for a while, but we've been iterating a lot on our software that runs on the camera. So that is finally now in a pretty good place, but it has been like a real point of learning for us, and something that we want to, there's really a lot of thinking about, okay, well, what does the future really look like for cameras? And so we have some ideas about this, and they're ideas that we've just started to act on. So they're very early ideas, but we've got some proof of concepts that we're working on. And so just to kind of reiterate a little bit, I talked a little bit about what the problems were with subsea cameras in the industry right now in general, but still the performance to cost ratio is not that great. They're not very flexible. There's not very many options for still cameras, or they're just not very good at taking stills. And people are expecting a lot more from cameras in general. And no one, including us, are really at the level of both smartphone and modern drone, like aerial drone level imagery. So we want to change that, and we've kind of dubbed this as the RockCam. It's kind of a working name, and so we want to use a smartphone lens module that has optical image stabilization. We want to use likely the IMX 989 sensor, which is a 50 megapixel sensor. So that can output about 8K video, or it also allows us to do digital image stabilization and all of the fancy stuff that is happening in GoPros and other modern cameras. Right now, we're experimenting with the Rockchip 3588 processor, which has video encoder, very powerful video encoding for it's very, very good value. And it's capable of doing 8K video at 60 FPS and has a lot of really interesting imaging capability in the imaging processor. So we can do optical image stabilization, we can do digital image stabilization, we can have autofocus or variable focus that actually works intuitively underwater, which is really difficult. We want to make the entire stack open source, including the hardware, which is a big thing. So we want to be going through this process of learning and developing the software and the hardware with the whole community, because we feel like it's really needed. We want to make it obviously low cost, and we want to put a lot of effort into accurate color correction and white balancing algorithms as well. And I'll pass it off to Kenneth to talk a little bit about our efforts in acoustics.
So as Eldin said, imaging is really important for subsea robotics, and probably the next on the list is acoustics, right? Sonar is how we find our way underwater when visibility is poor. Right now, however, the options available on the market, pretty much there's just super expensive black boxes, right? We don't have access to the signal chain, and the cost is prohibitive. We do have two products right now, the Ping 2 and the Ping 360, and they're great, but actually not all of the IP is ours, and so we can't really base a roadmap of acoustic and sonar products on them. So, And in addition, the localization, like USBLs and modems and stuff, super new technology, and we think that that the market needs that. So we're starting, I'm going to say, carefully, and we're imagining a development board. We think this is good for a number of reasons. One is it will allow a whole bunch of users who want to experiment at all different levels, and experiment with different sorts of acoustic technology and acoustic applications, but also a way for us to start developing our IP and our product portfolio in a kind of a controlled way, and then later we can then roll that out into a whole bunch of different products. We plan for it to be flexible and modular. Incidentally, there's a picture of one of the early prototypes there on the top left, for those who are interested. And we want a totally transparent signal chain. So from the RF all the way up to image generation or data, right? Or anywhere in between. And of course, that's going to help a whole bunch of folk, including the AI folk, who probably want to access a signal chain at a pretty low level. And as with all of our other initiatives, we're planning for it to be fully open source, even down to the hardware level. So there's another tiny little snapshot of it. So for this initiative to work, we want to build a community around it. And then hopefully we and everybody else will then use this as a foundation for learning and developing all sorts of cool products. Echo sounders, scanning sonars, side scans, hydrophones, DVLs, USBLs, acoustic modems, and even all the way up to like multi-beams and so on. So we've got big dreams, and this is us taking a pretty decisive but first step. So with that was kind of a really fast-paced buzz through of all the things that we're doing, as well as some insight into who we are and why we do the things that we do. So I hope you know us a little bit better. We also hope that everyone is as excited as we are in all of this stuff, because we're doing some really cool stuff, and it's just going to get cooler. And finally, let's talk about this, not just now in this meeting, and we're hoping that there's all sorts of juicy questions that we're going to dig into, but beyond that, right? We're trying to build some community. We're trying to solve some problems that we face, but also we know that everybody else faces. And we would love to get feedback and really make sure that we're heading towards some really awesome and meaningful solutions.
Amazing. Thank you both so much. If you want to go ahead and stop sharing your screen, we can dive right into questions. We've had quite a few come in during the presentation portion. And so if you have questions, keep adding them to the Q&A box. And then I'm going to go ahead and start it off with a question that we received throughout your presentation. Folks are really excited to get a handle or their hands on your products. And so we've had many questions come through around when items will launch and the timelines to bring these products to market, such as the RadCam. Can you share more information about that?
Well, sort of. We ask ourselves these questions a lot too. And so the challenge here is we're trying to do some really great things, but we also recognize that they can't get out too soon. We want to make sure they're really pretty hardened so that we don't disappoint anybody. I think we hinted during the presentation at the order that things will be coming out the door, and also the level of priority that we're giving to them. But with our pretty tight team that we are really focusing on a lot of these things, we're doing it just as fast as we can, because we want these things out there, and for us to use in a much bigger way, just like everybody else does. So I'm sorry we can't give any more specifics there, but we're really excited and impatient.
And we've never been closer.
Love that response as you guys are innovating new tools and technology to go into the harsh environments. And so we had a question from Maximilian, who is an engineering student, and he's interested in applied hands-on technology. They are curious how Blue Robotics balances accessibility with technical robustness when designing products for, as we just mentioned, such harsh and demanding environments.
Well, so that's a big topic for sure. If I interpret accessibility as making things that a very broad group of people are able to use, obviously, as Eldin said earlier, we've been targeting the really hands-on user base, that people who are technically minded and can do stuff. And part of that is very pragmatic, right? Those are the people who tend to adopt things first. And as we make things as fast as we can, they're a really easy group of people to hand them off to. Beyond that, obviously, we also would like all the other people to be able to use them too. And for that, we try to build really great documentation. We have this forum where people can post questions. We have a lot of video tutorials. We try to make it so that people can follow a recipe and be really successful. But we also recognize that there is a design component to accessibility as well. And so that just adds yet another layer of complexity to our work. And we recognize that we're always balancing, can we get something out fast so that people can have, anything, and then iterate on it and get them, make it so that even more people can benefit.
Great response. And he had another follow-up question. We have a lot of students and early career engineers in the audience, and they're curious, how can they best prepare themselves to contribute meaningfully to the marine robotics industry?
Well, the easy answer is design stuff, not even just for the marine robotics space, but just get good at designing things. Obviously, if you apply it in this space, you'll learn a lot of the necessary tricks for how you keep water out, which is kind of fundamental to what we're doing. But the more that you design anything, the more you're going to get your head into that space of how to make really good products. That I would say is pretty fundamental.
Mm-hmm. Yeah, I think just to add on to that, I think not when we're hiring new engineers, new people on our hardware team, a lot of them don't actually have subsea experience at all, and it turns out that it didn't really matter as much as you'd think. We're really focused on your ability to problem solve, and just have a lot of evidence of creativity in your design, and really focus on your first principles. So
great. Thank you all so much. And thank you to the students and early career folks for being here. We had a question from Chris around innovation. Do you all plan to build your own line of sensors such as conductivity, pH, dissolved oxygen, turbidity, or others?
Yeah, it's a great question. So yeah. So we've been thinking a lot about specifically connectivity, and so that we can do better CTD or have a CTD. It's been a topic that's come up a lot. It's not super clear when that's going to drop, but it's something that we've been talking about a lot, and is something we're really aware of. That is definitely a gap in our offerings. So.
Thank you, Eldin. And then another question, have you thought about developing a rim-driven thruster?
Yeah, we've thought about it. They're not there's some cost benefits to them, and I think the main issue with doing with them is that kind of inherently your uh, the how much you need to control over a spinning surface over like a large diameter, it becomes really hard and becomes quite costly. And so we've thought about it, and in the cost kind of benefit analysis of a new thruster architecture, it really didn't. It wasn't. We weren't able to scale it down enough in cost, and it didn't seem to make sense from a first principles perspective for us to just to move over from a like a central axle rotor. um, yeah, just the bearing surface speeds are high, and over the efficiency and usability gains were just not there that we found. So,
and we don't get the benefit too of being able to have a multi-purpose thing that can be kind of a general purpose motor and a thruster, which is where we are right now.
I think there is definitely some use for larger, much lower kV, higher torque, like gimbal style motors in subsea applications, and gear motors as well. But yeah, but as far as rim drive thrusters go, it's yeah, we just couldn't see the real benefit.
Thanks, Eldin. And that kind of adds to this question. It seems like you guys have a lot of requests for products and there's a lot of needs from your customers. So how do you prioritize what your team focus on when there are so many competing needs?
That's an amazing question. It's like yeah, I feel like we ask ourselves that every day.
Yeah.
Because I mean, we're a pretty small team. We have I think each of our kind of product lines, there's whole companies that are dedicated to them. We've got maybe 10 different product lines: acoustics, cameras, ROVs, surface vessels, propulsion, and you'll find a subsea company doing one of those things really well, and we're trying to do them all really well with a really small team. So it is really hard. I think when we're looking at something, kind of the whole list of all of the requests from the surveys and our whole roadmap and all the things that are in front of us, we're really trying to distill what are the real what are the foundational components that are going to enable other people to do stuff on top of what we're doing. So an example of that would be like the Blueberry protocol that we're talking about, or like it's like boring, arguably boring stuff for many people, like a penetrator or like a nut or like an enclosure or something. It's usually quite basic, and usually we'll run into these problems like when pretty frequently, like, oh, okay, we don't have a connector or something. It's like, okay, there's these very obvious things that we still don't have in our industry that feel like once we get over that hump, there will be a lot of things that we could be working on, and yeah, I don't know, we'll always be juggling that.
And so there will always be way too much to do, and we'll love to get to all these things, but in the meantime we just put one foot in front of the other and do the very next thing that we think will generate the biggest impact.
Love that response. And then you mentioned your Blueberry project or protocol. We actually had a question from Mateo. He is curious, can someone only buy a camera, cable, and monitor with the Blueberry project?
Yeah.
I'm just parsing that question. So right now we're actively prototyping with ESCs, servos, lights, Ethernet switch. Like there's a whole bunch of things. The intent is that pretty much every component that you would tend to hook up in a vehicle, that we will address that over time. Sonar systems, etc. So because of course it's an overall it's in the Ethernet ecosystem, we also can't step on all the other things that people might hook up that are talking Ethernet. So all of these things we're hoping to, if not support, at least not hinder.
That makes a lot of sense. And then looking to the future, we had a question. What are the end user applications that you're most excited about with the new camera and acoustic products you're developing?
Okay, I can speak to cameras if you want to speak to acoustics. I think there's yeah, so there's some pretty exciting things that people are already doing and have been doing actually with cameras. Just I think we're mostly excited for those things to be happening at a greater scale. I think there's a lot of awesome examples of people using them, using cameras for doing photomosaic surveying, for doing photogrammetry. There's some incredible examples of that, of photogrammetry work that is, it's just so cool to see, like a 3D model that's completely like textured properly, with all of the image information. And I feel like that really is being able to localize that to the earth frame properly, and have more software tools that are open source, and have cameras that can do photogrammetry that are lower cost, is going to probably, and make photogrammetry a lot easier to do on our platforms, is probably one of the things I'm most excited about, because it's just going to be such an amazing tool.
As far as sonar and acoustics are concerned, I think everybody wants something like a DVL on their vehicle. Everybody wants some sort of accurate positioning, whether they're doing remotely operated vehicles or especially when they're doing autonomous vehicles. And any multidimensional imaging, of course, is super important. And right now, there are products available, but the price points are still, where many of our users just don't have access to them. And so we would really love to see some of those things become even more easily available for everyone, because they just add so much to the sorts of things that you can do, especially in water that you've got visibility of like 0.5 meter or something.
Amazing. Thank you. Lots of questions coming in. Seeing we have just 5 minutes left, I'm probably going to ask the last 3 questions. And this question came from Brad about a future product. Do you have any plans to develop a subsea battery?
Yes, we do. Batteries is definitely, it's like way on our, it's right smack in the middle of our list of critical things that we would really like to get to. As Eldin said, there's a whole bunch of even more fundamental things that are taking our time, but batteries are definitely something that is smarter, something that doesn't require so many enclosures to be cracked open, and that sort of stuff. So yes, it's definitely on our list. It's not getting the love that we would love to put to it at this very second. But actually we are thinking about it, I'll say on the back burner, but it's not very far back. It's the medium close burner.
I feel like you guys have a lot on your plate. So when it comes up, Brad, head to their website to find out more information. And then another question, you guys talk a lot about open source. So where does documentation become critical in bridging the gap between capability and deployment?
Yeah, so it's very critical. right? For somebody to dive into new software, new code base, to adopt it, to interact with it, obviously the documentation has to be there. The big challenge is with our limited teams is how much effort can we put to the actual development of things and how much effort can we put to the documenting of things. And that's a constant balance. But it is very important because especially as we try to build these bigger communities, if we have these barriers in the way, right, where people can't navigate to where they need to navigate to within a code base or with multiple software things or whatever, then it's pretty, they're not going to pick it up and use it.
Amazing. Thank you. And one last question. This community on this webinar really wants to get involved, and they had a question on how they can get involved with acoustics development.
Well, we don't have a specific place in our forum yet for it, and as we said, we're developing hardware right now as part of our initial. We're calling it the Ping Development Kit. These are all things that will come hopefully sooner than later, and so watch this space, I guess. Would be my suggestion.
Amazing. Thank you, Kenneth. And what I'm going to do is I'm going to drop a link to your guys' forums in the chat for everyone. We had so many questions come in and we were not able to get to them all, but you can ask these questions and participate in the conversations on the forums, as Kenneth just said. And Blue Robotics also shared with me a link to a YouTube if you guys want to see their products in the wild to kind of learn more about them. And so with that, I want to thank you to everyone who attended the webinar, and especially Eldin and Kenneth from Blue Robotics for this amazing and informative sessions. We've gotten a lot of kudos in the chat, and the conversation does not stop here. As you guys visit the forums, be active, and we're just really appreciative for you guys sharing your knowledge with the MTS community.
It's been great.
Yeah, thank you so much.
Thank you very much.
And thank you to everybody who came.
Have a great one.
Okay.
Happy Wednesday. Bye, y'all.